Hi guys, welcome to this Wintellect webinar, Wintellect/Atmosera webinar. We're going to be talking about optimizing compute on Azure Kubernetes services. So today we're going to be looking at a lot of different options for how you can tune the compute of Kubernetes on Azure to scale up dynamically and optimize it for your kind of workload. So that's kind of the content that we're going to be looking at. So we're going to be looking at the kind of the Kubernetes side of things, as well as how you can take advantage of that with your workloads and how you would create Kubernetes manifest files to take advantage of some of these features on Azure Kubernetes services. So that's the intent of today. I'm Blaze Stewart. I'm an architect at Wintellect, and I'm a Microsoft Azure MVP, and I've got a bunch of certifications, and I specialize in apps on Azure, which is kind of a whole gamut of things, including infrastructure, platform as a service, and data, and then how all that kind of works together to bring apps to fruition. So this is one area that I like to work with. So Kubernetes is one of my favorite things. So it's about me, a little bit about who we are at Wintellect. We're a consulting/training company, and we recently were partnered with or merged with a company called Atmosera, and Atmosera provides MSP services, so managed services. So if you want to run workloads on Azure and you don't want to manage Azure, we can do that for you, but we can also help you along their journey into migrating to Azure or anything that you might have in that context. So let's dive right into the content, what we're going to be talking about today. So kind of the basic concept of everything that we talk about today is based around this idea of a node pool. Now on Azure, in Kubernetes, node pools exist. This is not a Kubernetes on Azure concept. This is a concept that exists on any manifestation of Kubernetes, regardless of the provider. It could be Amazon, it could be Google, it could be Azure. The concept of a node pool is really about defining a set of nodes on Kubernetes that are all alike, essentially. So if we had an AKS cluster or any Kubernetes cluster, we're going to have a set of nodes that are all going to have basically the same operating system, the same kind of compute configuration. They're going to have a lot of those same kind of features, all going to be running the same version of Kubernetes, etc. And they're going to be alike in that context. So that's going to be one node pool. What we can do with Kubernetes, though, is we can create additional node pools that have different features. So in the case of Kubernetes on Azure, I could have Windows nodes and Linux nodes, and that could be two separate node pools, and they would each have a set of VMs within that context that run a given operating system. So one was going to be running Windows as the host operating system and therefore can run Windows containers. One will have Linux nodes and Linux under operating system and therefore can run Linux containers. And that is a supported scenario on Azure Kubernetes services. Now, something else that you might want to do is have different kinds of compute that is optimized for different kinds of workloads. So one thing that you might want to think about is having smaller or larger VMs, for instance. So if I had a workload that required a lot of memory, for instance, I could use M series VMs on my Kubernetes cluster, and that would be one of my node pools. And I would configure it to have those VMs, and then I might have another node pool that has smaller VMs, such as B series VMs that are for burstable workloads, such as web servers and things like that are very useful under those scenarios. So in that case, I might have a database cluster running on my node pool with my M series VMs, and I might have my application front end running on the B series VMs. And that would give me something that is going to be more optimized in line with what I'm actually doing. So that is just one of the possibilities that you can do with this. So is different kinds of compute. And another thing that you can do with it is different versions of Kubernetes. So with Azure Kubernetes services, you can have a wide range of different versions of Kubernetes running, typically on a minor release version. If there is a certain feature that you want to take advantage of, you can say, I want this version of Kubernetes to run on these nodes. And it will still work with other Kubernetes nodes that might be running an older version or a newer version, depending on what your scenario may be. So one thing with Kubernetes is it's constantly changing. And some features that were introduced 10 versions ago or 10 minor versions ago are now deprecated, but you haven't updated your code yet. So it might be the case that you need to run that particular application on an older set of nodes so that your features will, that your application will still run without having to change the code, but you eventually will need to upgrade because that feature will eventually be deprecated, no longer supported in AKS, but it does give you the ability to have a spread of different versions of Kubernetes running inside of an AKS cluster. So that's kind of what you can do with node pools. Now, there's a lot of other things you can do with it. You can wrap up different security requirements around them. You can separate the subnets or the different. You can do different kinds of network configurations where I might want to put front end and back end node pools and things like that, and use network policies. There's a lot of different things you can do with node pools. But basically, the bottom line, the most fundamental concept of this is that you have different kinds of compute dedicated for the VMs that compose that node pool, be it operating system or hardware configurations or versions of Kubernetes, and you can kind of mix and match that accordingly. So from there, let's talk about what we can do to kind of shape this story and talk about one thing before we get into some examples of this. And the next thing is I want to talk about is auto-scaling. Now, when we look at node pools are the ability to have different kinds of compute. Now, with AKS or Kubernetes, you on Azure, you can have auto scaling turned on or off for a given node pool. And what auto scaling does is it allows you to scale the nodes dynamically based on the load of that node. It's based on the number of pods on that node. So this scales the nodes. This is not, however, scaling the number of pods. That is managed by the controllers. So this is going to be responding to the number of pods running on a given set of node on a given node. So if I set the max number of pods to say 12 on a given node for a given node pool, what this is going to do is it's going to add new nodes whenever a certain threshold is exceeded. So if I get up to 12 pods on one node, I'm going to add another node to that so I can continue to scale on up to a maximum number of nodes that I might just define for my node pool. And as that demand goes down, if over a period of time the number of pods decreases and I no longer need the maximum number of nodes, then what Kubernetes will do is it'll shift some of that work back to more to other nodes, and it will start to deprovision the nodes to bring the compute more in line with what you're actually using. So that auto scale feature allows you to dynamically scale your nodes per the number of pods that you have running on them, and that brings your compute very much in line with what you're actually doing on the actual node. So you don't have to pay for 5 nodes 24/7, even if you're only using, say, half of that. So this will allow you to dynamically scale in that context. Now, you don't have to auto scale on Kubernetes. You can manually scale if you so choose, and you can do that by manually adjusting them or scripting that out. But the auto scale feature is just basically polling the nodes for how often it needs to. Say, 10 seconds is typically the threshold that it does it on, and it will say over a 10-minute period, if I need 10 more container or 10 more pods to run on this, then I'm going to start adding more capacity, and then it will continue to add capacity until it reaches the maximum, or it's able to satisfy the desired number of pods within that given node pool. So that's kind of how that works. It's just basically on the number of pods that you define, the maximum number of pods that you would define on that given node pool. And by default, I think it's typically around 30. You can go up to 500. So it just depends on the kind of workload that you intend to put on that node pool of how many pods you want to be on that node. So if it's a small pod, running a small container, that is. So it's something like a node app. It's just an API. There's really no state involved. You're not going to be using a lot of RAM or compute with that. You might be able to cram 100 of those on a single node. But if it's a large database, for instance, you're running a database cluster inside of pods, you might want 2 or 3 per node. So that's something that you would have to consider whenever you're building out your node pools and trying to adjust these whenever for your liking. So let's just try to consider what those are and what those look like, the workloads that you intend for those, and then plan the node accordingly And that's how we would determine how many max pods we want, and then the kind of compute that we want to use, and then the scaling story that we want to use. So with that in mind, let's talk about the different kinds of ways that you can get these nodes up and running. So the first one I want to talk about is a node selector. And this is probably the most basic one that you can do on Kubernetes. Now, a node selector is pretty basic in that what it allows you to do is take a node pool and say, this node pool has this label, B series VMs. And from that, you can basically say, I'm going to run this set of containers on nodes that have this label. And so if I say B series VMs for my node, then this one will go out there, find a node that has a label called series and a value called B series, and it will run this particular application. So let's go to the Azure portal and take a look at this and how it works. And that will give us an idea of what we're going to be looking at here. So let me pull this up, bring this over here, and I'm going to show you my little cluster that I set up for this. And I basically set it up for this particular label right here. So if I come in here to my Kubernetes cluster and I look at my node pools right here, I have defined 4 node pools in this particular cluster. And this one right here, I've called it B series, but if I drill down into this particular node pool, I have some labels on it. So come on, Azure, help me out here. So this is the label. Let me zoom in here. This is my label right here. We're going to talk about taints in a minute. This is my label right here that I'm using for my node selector. And this is a B series VM. It's a standard B2, which I think is 2 cores and 8 gigs of RAM. So it's a B series, so it's burstable. It's not a big VM. But in any case, it's labeled B series. So what I can then do is I can say with a node selector, I want to choose this particular node pool for my workload. And I do that by using a Kubernetes manifest file whenever I'm defining my specifications for my pods. So what that's going to look like is something like this. Let me bring this up over here. I have, this is my demos right here. Node selector. And let's look at this particular manifest file right here. Open with, okay. So this is a pretty typical looking manifest file. It's using a load balancer. We're not going to talk about that today, but I'm using a deployment controller here. And down here is my containers. This is my pod spec right here. And this is the one that defines come on. I collapsed it. That's what happened. This is the one that defines the pod specification. So it tells me what container to use. And then it also says node selector. And the node selector is what I want this to match against whatever is inside of my label right here that is a part of my node pool. So this I create whenever I go over here to create a node pool. If I add a new node pool, when I define this as part of the creation process, I can go over here and I can add labels to it. And this is where I define that on Kubernetes. You can find that with ARM templates as well. That's where I define that. And so whenever I get this node pool created, I have, as part of that node pool, a label that says B series, and then I match that with my node selector here. And that was going to tell this particular set of nodes right here to run on that B series node pool. So I'm going to change the scale of this. I had these scaled down because I didn't want to incur costs. I'm going to scale this up to, I'm going to give it a max of, let's just say I can have a max of 5 nodes on this and apply this. And this one has, I think, up to, I think it's 100 pods or 30 pods per node. Nodes, I think it'll take up to 100. Can't remember the exact number that I defined on this particular node pool, but in any case, what it is just basically there it is, max pods per node, so 30. So if I deploy this, it should, in theory, scale up the number of nodes on this particular node pool right here, because I have auto scaling turned on to all 5 nodes, because I have told this to create 150 replicas. That means 150 pods based on this deployment. So let's go and spin this up and see what happens. So let's go over here. I got a command prompt here. Let's do kubectl. I should be able to, I should be already connected to this. See if this pulls up. Okay, kubectl, get pods. And there's none that are defined as of right now. So that means I don't have anything up and running. So I'm going to do apply -f, and I'm going to do this particular YAML file. And this is going to then create a whole bunch of pods right now. And it's basically creating 150 pods on those nodes. So if I come back over here to the Azure portal, I should be able to see those pods coming up as well. If I come over here to my workloads, I can go over here to Node App, and it's going to have a lot of these pending and running, depending, because it's going to have to create a bunch of nodes to create all to satisfy the demand for this, because I created 150 pods, and that is basically going to say I'm going to need a lot more compute than what's available. So I should be able to come back in a minute and see my my node pool create a bunch of new nodes. It's going to scale this B series up right here to 5 if everything goes right. And that usually takes some time. It doesn't happen right away, but if it's not currently provisioned, it will start to provision more VMs as that demand increases. And that's exactly what this is. This should do over time. So let's continue on, and we can come back and check this, because it's going to take some time to get this running. But once this gets up and running, we should be able to see, this have a little bit more assignment to it whenever that's said and done. So let's go back to our deck and look at the next topic, which is going to be another way to distribute work. This one is more explicitly defined, which means that just basically saying, run this workload on these set of nodes. There's another way to do this with Windows containers. And this is something that you need to use whenever you're working with Windows containers. So what I'm going to be doing here in this case is not using a label. I'm going to be using a label that's not one that's assigned to the node as much as it is a part of the that I created. This is one that's just part of the actual node itself. And this is a system label that's called Kubernetes.io. That's how I know it's a system label, and it's /OS. And I'm going to be looking for Windows. And when I use node selector for Windows, I need to tell it to use Windows nodes based on the operating system, so that I don't get a bunch of failures. And sometimes Kubernetes will, if it can read the manifest file for the container to say, oh, that's a Windows containers, and it'll try to figure it out. But in my experience, it's better to just go ahead and define the node selector there to tell it to use the OS for Windows containers, and that way you don't get a bunch of false delegations or any other kind of problems that way. And so this one will use the Windows, the system label to determine which operating system to use, and that's going to what I'm doing here. So to show you what this one looks like, I can show you another manifest file. It's going to look a lot like the one that we just saw, and this one uses Windows containers. It's the same story. The only difference here is this one has a Windows Server container, and this is the exactly same thing that we just saw. It's using a container from Microsoft to say use server core IIS. And if I wanted to customize that container, I can put my workload in it. I didn't really do that for this particular demo, but I'm using a node selector that says use Windows. So I can do the exact same thing that I did for this one, that I just saw for the one I just did. I can do kubectl, and then I can do it apply and -f, and then I can do scale.yaml. And then that's going to create a set of pods for this particular workload, this IIS app workload. So if I go over here and look at this, if I do get kubectl get services, that should give me a list of the services that I'm exposing. It's bringing up the IP for that. If I do get the deployment, It's showing me my IIS app there. It's bringing it up still. And if I look at this right here, I should be able to see that running on my Windows nodes that I have defined down here. So if I come back over here to my node pools, this is my Windows pool right here. And if I come down here, this is my Windows node pool. And if I come back over here and look at my workloads, I should see my IIS app right here. And these should all be running on that node pool, AKS node right there. That's that node pool that is using Windows. And so I've mixed Windows with Linux in this particular configuration to kind of give me that blended operating system feel that I have here. And let's see if this is up and running yet here. If I come over here and I look at get services, there's my external IP for my Windows app. Let's pull that one up. And there's a IIS container behind that. That's the one I just created on the Windows app. And let's see about this other one for my little Linux demo here. And this is the one that Node app that I spun up 150 instances of, and this is the one that I spun up for the IIS instance. So that's all running on the same Kubernetes cluster on two different node pools based on node selectors. And one of them is using the system node selector, and one of them is using the one that I defined based on a label B series. So let's see if this other one came back up yet, just to see how our health is looking here. Still a few outstanding. Let's see how many nodes I have come up on that B series, just to see if that's actually scaling correctly. Yeah, so that did scale. So we did see that scale up according to design. That Autoscale did work. So I did get a 5 out of 5. So it basically scaled to the max number of nodes available on that one. And there's actually a few pods that won't be able to start on there because the node count does include the system pods that it starts on the nodes. So I have 150 pods running across 5 nodes now, and it did auto scale those. So that I do know is working. So that's node selectors. Let's go and look at another way to do this based on something that's not so much explicitly defining it, but based on more of an exclusion model. That is, using something called Taints and Tolerations, which basically allows me to define a way to exclude workloads. This is more including workloads. So I'm basically saying run workloads explicitly on node pools that have this label. Taints and Tolerations kind of reverses that. And let's take a look at kind of how this works. It's a little bit more complex. This is very simple. The Taints and Tolerations is a little bit different in that it's more of an exclusion model. So this one basically says, what I want to do with my nodes is I want to so-called taint them with some kind of value. And what that basically means is I want to create a set of nodes that will only allow certain pods that have a so-called toleration on this particular node pool. So this allows me to exclude node pools from being considered for workloads. And so I can take a workload, deploy it to my cluster, and what Kubernetes is going to attempt to do is distribute that across whatever nodes are available, except for nodes that aren't tainted. And nodes that are tainted require that the workload have a toleration defined so that they get distributed to that workload. So unless you define the toleration, it will try to ignore those nodes for the workload that you have intended for that. Otherwise, it'll distribute it across whatever's available. And so if there are no taints, then it will deploy it to that, even if a toleration exists on the workload. So it's not preferring it. This is more excluding workloads from it unless a toleration exists on the actual manifest, the Kubernetes manifest that we are looking at. So the node selectors for explicitly defining nodes with these labels. This is saying don't schedule anything unless the toleration exists, and then Kubernetes will attempt to distribute the work across all the available node pools unless the toleration is defined, and then that way it will include it. So let's go and look at an example of this that I have. This one's a little bit because it kind of turns the logic on its head. It's a little bit harder to get your head around, but it does give you a lot of different ways to control the nodes more implicitly here. So look at this particular one example here has a toleration defined on it, and this particular toleration says I tolerate. This one says you can schedule this one on a node pool that has node app defined and equals node app. So basically, where this key exists and this value exists, and the effect is no schedule. So if that taint exists, then this pod or this workload can be scheduled on that particular workflow, that particular node pool. If the taint doesn't exist, that doesn't match this, it will be excluded. So to define this, what I did is I went over here in my node pool, and I on my D series VMs, I added this particular node pool. I actually have label and a taint on it, and this is the taint that I want to match. So if I was to deploy this without the selector, what's going to happen is it's going to distribute this workload across all of the available workloads, including if I didn't have that toleration defined, it would attempt to distribute the workload across all of the available node pools that would be able to run this, except this one. But because I have the toleration turned on, it will allow it on this particular node pool. So let's go ahead and delete this one right here for this B series, and let's reapply it. I'm going to delete this one right here. And that's going to remove all of those 150 or so pods that I created. And let's, I'm going to change the name of this one from Node App 1 to Node App 2, just for good measure, so that it comes up as a different name. And we will deploy this one separately. And so it's a different workload. And just change everything that says Node App 2 to Node App 2. And the rest of that should be fine. So I'm just changing this up a little bit, and let's open up a new command prompt here, and let's apply this one, and just to see what it looks like. So let's go to kubectl apply -f, and let's do scale.yaml, and I'm in that taints toleration folder, and that's going to create Node App 2 right here. Now Node App 2 should come up. And if I come back over here and look at my workloads on this particular tab, this one's coming up. And I should be able to see this one's going to distribute it across whatever's available. And I'm getting some B series one. It's attempting to create it on that Windows node pool. That's why we need to explicitly define that. That won't work. It won't allow that. Actually, that'll crash. And I should see some of the D series around here as well, wherein I have a D series VM that's coming back from wherever that toleration is. So unless I changed something about my toleration when I did that replace all. So let's see. Let's try to go it from the other way and look at my node pools. And let's come over here to my D series and nodes. And let's drill down to this. Here's my taints, node app, node schedule. And I'm sorry, node pools. That's what I want. Oh, that's why it didn't work. I have my Node app right here. This is this is not correct. I had this should be not allowed right here. So if I update that, it should start distributing some of that to my it should start distributing some of that to my other node pool there, because I had the wrong value in there. That's why I wasn't showing up on my B series, D series. So, in short, what happened there with it, what I didn't allow for is it was disallowing for this particular workload to be distributed to that particular node pool because the value was off. And I said node app allowed. I had node app equals node app in the taint, and because the taint didn't work, the toleration didn't match the taint, it was not scheduling to that node pool. So that shows you that it was ignoring that based on the taint. But now that this toleration is right, it should start distributing some of that workload to the actual D series VM. So that is the taints and tolerations and how they work. So if I go back over here and look at this, I should start to see those particular workloads over here with that node 2 start to come up on that D series. And it's putting some on the agent pools, and some of them, it should start to distribute them to the D series VMs. Let me try that. So that's how that works. So with taints and tolerations, we'll come back and look at that as soon as that figures out what it wants to do. So the last, there's two more concepts I want to look at here, and taints and tolerations is one way to exclude workloads from nodes. And node selectors is how to how to explicitly define workloads for specific nodes. There's another way to do this using something called affinity. And an affinity is a way to shape behavior based on weights. So this is less explicitly defined, and it allows you to build your Kubernetes manifest files to have a way to define where things are going to go whenever they're defined in a way that is based on a weighted preference. And so it's more of a heuristics based approach to scheduling versus more explicitly doing it through node selectors and taints and tolerations. So what happens in this case is with this affinity, I have required during scheduling, ignore during execution. In order for this affinity to work, what I can do here is I can say where these labels are true, where the series is in D series or B series, I can say select those, right, for this particular affinity. And if I want to give it a preference to a specific series where there is available space, I can say first prefer this one, and this one is going to prefer B series. And that's what that's going to do is from the required values right here, it's then going to give preference to another subset of that. So this one basically tells the Kubernetes cluster to prefer the B series over the D series. And as long as there's space available on that B series, prefer it. Continue to add weight to that until at such a time it's unavailable. And then maybe you can then start going to this D series as a fallback rather than preferring them all equally. And so this is a way to prefer specific workloads rather than just explicitly defining them, like what we saw with taints and tolerations. So this one, I like this model for I don't care kind of workloads, but I generally like to use node selectors more than anything because that I tend to think of specific node pools in mind whenever I'm building out a specific kind of workload that I intended for it. So node selectors are a way to do that, defining the operating system, and then also defining it based on labels, tells it go to these specific nodes, and that's the one I'm intending for this workload. So front end or back end, I might label them that way, or it might be a database node pool or what have you. And that way you can kind of shape the behavior based on that. But this is for those wildcard workloads that it can just use whatever compute's available, and that way you can use this one right here. So let's go and look at an example of this particular one based on something that we just saw. This particular one is using Affinity right here. And this is exactly the code that we just saw. This one is using an Affinity based on that, what we just saw right there, using the this particular requirement. Oops, I skipped back. Using the required during scheduling, and this one is saying preferred during scheduling and or during execution. And this one will then execute those pods on these particular, based on this particular affinity. So let me start this one up. And this one is called node. Let me rename the workload here, and let's name it to workload 3, just so that we can have a clean name there. And let's save it, and let's apply it. And let's do kubectl apply -f, and then that's going to create my third workload there called node app 3, and that's going to put everything on those B series, because I think I purged all those B series VMs, and they currently they'll have some of this. They should have some of this other workload, this node app 1 running on it. Let me refresh this right here. Or sorry, node app 2 running on this one. I should see some of those running on that particular the B series right there. And there's some of that D series that we saw, because that taint, I fixed the taint and toleration there. So B series agent pool is, just an open one. It can run on that one, whatever. This one right here is it's trying to schedule it on that Windows node pool, and that's not going to work because the operating system won't pull the image. But this one is running on all of them, especially with the taint and toleration. This one is going to put them all. It should put them all in the B series because of the affinity. Because I just created 10 of these, and because of the affinity is skewed more towards the B, it's going to put this on the B series node pool. If I spun that up to say, let's say 170, then that's going to exceed the capacity of the B, and it's probably going to start running out of space, because I do have that taint on the D series. But in any case, that's what it's going to continue to prefer, that B series until node pool, until it starts to run out of space on that and it'll start to delegate that to other node pools as it finds them available. But I don't think this particular example will work because of the taint that I have on that. But what I could do is do something like this, is put a toleration on that in addition to the affinity, and the toleration will work with that. So that's under the container spec, and that would probably allow me to use the D series as well. Didn't like my indentation. We'll worry about that some other day, but I could put that on there if I chose to, right here. Let's try it one more time. Okay, that worked. It allowed me to do that time, and that should start to schedule those on these right here, based on that toleration that I added to it. So if I go back to my workloads and see that, I should be able to see node app 3 coming up on more than the B series. It's going to continue to prefer that B series until it runs out of space, and then it's probably going to start scheduling that on other nodes as it can find them in that D series, because the toleration exists now. So let's look at one last concept, and this is one that kind of combines taints and tolerations as well as node selectors, and this is something that is used for a different kind of workload, and this one is virtual nodes. Now, with Kubernetes, whenever I define node pools like this, what we've seen so far, these are explicitly defined, and this is done by way of VM scale sets. Under the hood, this is running virtual machines on Azure, and you can go drill down into the resources and you can see what those are. Virtual nodes, on the other hand, are transient type workloads that get defined based on Azure Azure Container Instances. And what Azure Container Instance is, basically works as a way of defining a instance of a container that runs on a what we might call a serverless model. In other words, the compute is on demand. So as you create the pod and as you destroy the pod, that's the life cycle of the compute that runs that pod. This over here, the compute exists before the pod spins up and then after the pod shuts down. So on anything that's defined as part of a more explicit node pool, you're going to be billed for the compute regardless of your utilization of that compute or not. Azure Container Instances, on the other hand, are billed for the duration that you actually use the compute and not a second longer. So as soon as that pod is done running, the connection the billing stops. And so this one is going to be very much in line with your actual consumption. But I wouldn't encourage you to use this model for everything. And the reason why is because that could get really expensive, because it usually costs a lot more per time of unit to run Azure Container Instances than it does to run a VM 24/7. However, it can be cheaper if you're doing it for more ad hoc type workloads that are running on a more transient type schedule. In other words, I just need to run a batch, say once a day at midnight, and I don't want to spin up a whole new cluster node pool for that. Well, I can put that on an Azure Azure Container Services virtual node that's running on Azure Container Instances. It'll run for 10 minutes and shut it down. That in the long run could actually be a cheaper option than, say, trying to maintain a node pool to run that one workload that you only need to run once a day or something like that. So that's basically what the use case for that is. But it shows up like a node pool on your container cluster. So what you can do is schedule it just like you would any of these other more explicitly defined node pools. The only difference is that the underlying compute, though, is going to be an Azure Container Instance running that particular compute. So let's take a look at this one. It uses both node selectors and taints and tolerations to define it. So let's look at this particular virtual node right here. And this one is using node selectors right here. And this is the node selector that I need for this one. I need to tell it what operating system I'm running it on. The role is going to be an agent. It's always an agent, and the type is virtual kubelet. This basically tells it to use virtual nodes. Right here is the type is a virtual kubelet, and the virtual kubelet is something that exists up in the Microsoft orchestration that tells it, oh, that's you're telling Azure Kubernetes services, I want to use virtual nodes by telling it by using virtual kubelet. And then the tolerations, you also have to define a toleration as well as to prevent other workloads from attempting to use that particular set of virtual nodes as well. So this one has a taint associated with it called virtual kubelet provider, and that has to exist in order for this to work. So you have to explicitly define it by way of a node selector, and the toleration has to be defined so that Kubernetes just doesn't try to assign works to the actual virtual nodes in that case. So combination of selectors and tolerations here, and you can definitely use these in conjunction with one another for the exclusion as well as the virtual as the explicit inclusion as well. For virtual nodes, it's required though that you do this so that it ends up on that node, and that way the work doesn't get delegated to something that isn't a virtual node. So let's run this one and let's see what happens. So let's open up this particular one in a command prompt, and let's go kubectl and this apply -f, and let's go keen. This is my, and let's let that one spin up, and we should see that come up on a virtual node inside of our workloads right here. Let's see, refresh this right here and see if I can see that that keen workload. And this is going to take a while to spin up because this is a fairly hefty container, and it also has to spin up the container instance to create this one. And so this one is a little bit heavier than other containers than what we've seen in the past, but it does taking a minute to spin up for that. So that is using a virtual node. So while that is creating, we can do some questions and answers. Let's see what we have here. And we'll come back to these and look at them. Let's see. Uh, so, so if you have any questions, go ahead and put those in the questions. I'm reading through those now. Um, First question is what creepy job AKS is scaling the count of containers? This is a comment that was related to scaling back the containers. Now, auto scaling for if you're going to think about auto scaling based on and you're concerned about AKS killing your container under the hood, what you that's really not autoscale wouldn't be intended for that. So the intent behind autoscale is where all the instances of your workload are identical to one another. So it doesn't matter if it kills a node, it can take the node down and reshuffle the containers to another node and bring them up into a healthy state. So you don't want to maintain state in anything that you're going to be using for autoscale. So it's generally intended for something that can autoscale, that is something that's more stateless, something that's more microservice oriented in that regard. So that's really what the intent behind autoscale is for it. If you need those to be explicitly defined, you wouldn't use autoscale. You'd probably use something like a manual scale to ensure that those nodes are available, just so you have an HA configuration for something like that. So the next question is, what if the B series node pool is not available? If the B series node is not available and you have the label on there, it won't schedule it. In fact, that's why you might want to use something like Taints and Tolerations or something like an Affinity in that case. But if the B series node is not available, that's usually because Azure's down, or you have the scale set to 0 or something like that, so it can't schedule it anymore, and therefore it doesn't work. Now, something I didn't talk about is something you can set up availability zones inside of Azure for whenever you define your scales, your node pools. Something that you can define as part of your node pools is availability zones. If I was going to create one of these, I can say 20 nodes right here and auto scale. Availability zones basically gives me different data centers within an Azure region. And so that says I want to create my Kubernetes cluster across 3 Azure data centers in the same region. So they're geographically located close to one another, but they're in different physical plants in a given Azure region. And so that way you can have redundancy available. You have better availability that way. You'll incur network egress and ingress charges across availability zones for traffic that goes between those different nodes. But that availability zone gives you better availability in that regard for availability. So if you're going to deploy this into an HA configuration, ensure that you turn availability zones on. Make sure you at least have 3 with 3 availability zones, and that way you get better distribution across the available landscape here. And I would set a minimum, like for a production cluster, I would say no less than 3, but up to 1,000 different nodes, for that given cluster. So figure out that scale what you need. So 3 is kind of a minimum for production, what I consider production cluster. That way you have a high availability across the availability zones. But you can have 1 for development and that kind of thing. So that's for availability in there. There's a Windows Virtual Kubelet as well. Yes, that is true. The comment was there's Windows Virtual Kubelet. Yes, there is you can assign virtual kubelets for virtual nodes for Windows containers or Linux containers. It doesn't really matter. Either one of those will work. So you can basically just determine what operating system you want to use. We were looking at that a minute ago. In this case, if you wanted to change this one to Windows, you could do that, and you need a Windows container, of course, but that is available Azure Container Instances does work with Windows and Linux containers. So that is one thing that you can do there as well. So next question is there, so the virtual nodes might be a good for Azure functions that need to be a long running workload. Uh, yes, if you're running your Azure functions in a Kubernetes cluster and those were running in a way that I don't think you could, no, you would use a function for a virtual node, because a function is event driven. So you need something, if you're going to containerize a function app, which you can do that. You need that's event driven, so that needs to be on a node pool that has the function running already. The compute, the long running function itself can run on node pools, but not virtual nodes. That the virtual nodes would be something that you would schedule using something like a cron job on Kubernetes. A Kubernetes job or Kubernetes cron job. Those are different kind of controllers that you have with Kubernetes, and you could create a Kubernetes job to run on those, and you can delegate that to run on a container instance using virtual nodes. That's the kind of the intent there, and so you can spin those up using some kind of scheduler that either you roll and you do through automation through something like a DevOps process, or you can schedule it using a cron job on Kubernetes to run, and then use node selectors right here for node selectors for taints and tolerations. Or if you're just doing something that's more demoware and you don't want to spin up a node pool, you can use virtual nodes. So like you just need to do a demo and you want to run that on the same container cluster and it's a dev cluster, virtual nodes are a great way to do that. I've done that before as well. So the Linux VK comes out of the box. Linux virtual, yeah, okay, yeah, that's true. The virtual kubelet does come out of the box. That's true. So let's go back and look at our workloads and just see how they're looking. So that we've given some time. We've done some Q&A here. Let's go back and take a look at our cluster. I'm going to throw this away and let's see if our see how this, yeah, these B series came up right here. Sorry, I'm going to look at my workloads here to see what these look like. This one is still bringing it up. That thing is struggling to find space because it's competing with this one. This one looks like it's swamped the B series. It filled that one completely up because that's got that taint toleration as well as affinity, and it's just out of space, and it's struggling to find any other space to run it. This one right here for this one is that's not the one I just looked at, I think. Yeah, it's just trying to, at this one, it's just putting them wherever. I think because this one is filled up that D series pool. This one, this one was the one that was running taints and tolerations, or rather, sorry, running the affinity, and it's running out of space. It can't find anywhere to schedule these nodes, these instances, so it's just not able to satisfy that. The IIS one is up and running, so all these are having a hard time because I literally just don't have any more space. If I was to add more nodes to these, it would be able to find more space to run those, and then it would be able to schedule it. This particular one is running on a virtual a node, so it has no problem with that. It's also got a taint toleration associated with it, so it does not have a problem running it. And let's just go and see what this one looks like. So if I do a kubectl get service, this one is keen. This is a demo that I do like to run because this one it's just something fun that I like to do in demos. And this one runs a little VNC client. And if I go to C:, and then I go CD, this is a little DOS game that I have here, and installs a DOS game. And this is actually like DOS box running in a container with a VNC client, and it allows me to use something like a virtual desktop in a container that's running on a so this is running a DOS virtual machine, a DOS emulator on a Linux desktop running in a container that's being streamed back to a browser. And so this allows me to play a game inside of a browser like this. So, it's just a fun demo I like to do. But this is running on a virtual kubelet on Azure. So, so that's That's it for that. So if there's no more questions, go ahead and pose those now. If you don't, I'll give you a few seconds to do that. I think that's all I have for you today. And thanks for coming out and for this particular webinar. We're going to be doing another one in about 3 weeks. We're going to be looking at storage, and we're going to be looking at optimizing storage on Kubernetes. And the storage that we're going to be looking at is like how you can use things like Azure Blob Storage, how you can use files, Azure Disk, and Azure NetApp files, and how you can connect that all back to Azure Kubernetes services, and how when you might want to use one of those over the other, and look at cost implications and so on. So thanks for coming out. I'll be looking for you on the future Winterlight webinars.